Thank you. Hello everyone and welcome to our lecture about with my desktop. Today we're going to deep dive into hVNC, some financial model basics. Let's see the agenda. So we'll start with what is VNC, in general, how it works. We'll deep dive into Windows internals, session, Windows Station, desktops. Then we will show how financial models works, what they try to do, what they try to achieve. We will continue with deep diving hVNC, show some of its dirty tricks, what it does, how we do it. Then we will show how we reverse the GOSI ISFB hVNC model. We'll show you the demo of how actually hVNC works and what it does. And we'll continue with some detection and IOCs. So, what is the difference between regular VNC and hVNC? It is very similar to the difference between cat and hcat. As you can see, the hcat is almost invisible, but it's still there. Who are we? We work for IBM Security Trusted at the Financial Malware Research Team. My name is Or Safran, and
so thank you all. Okay. So let's start with talking about remote desktop software in general. So basically it's a software that allows you to remotely access a computer across the network and control it. Originally it was used for technical support, so if you had issues on your Windows, instead of someone guiding you over the phone how to fix it, someone could just log in and fix the problem for you. So nowadays it's used mainly for maintenance of servers, administration, conference calls between companies, file transfers, and so on. So there are many implementations for it. There is the Microsoft RDP. There are many flavors of VNC, Citrix, LogMeIn, TeamViewer, and many more. So let's talk about what is VNC in general. It stands for Virtual Network Computing. So basically it's a software that uses the RFB protocol, which is the remote frame buffer. So it's composed of a server and a client, and basically it means that the server will send screenshots of his desktop to the client. The client will see those screenshots, and he will send back the input of his keyboard and his mouse. So this protocol is platform independent. You can use it from your mobile device, Linux, Mac, whatever you want. The default port is 5900, but of course you can use any port you want. And the desktop is shared. So if someone is connected to me using VNC, then usually if he opens some windows, I will see it. If he opens a browser, I will also see it. So many remote access Trojans use it. These are malware that usually used for espionage, for stealing your passwords, for seeing everything that you do, and so on. So in the first, let's dive a little bit into Windows internals. And in order to understand how hVNC works, we need to talk about sessions, Windows stations, and desktops. So they all are basically just kernel objects, like processes, threads, and other stuff. So they're securable. It means they have a security descriptor. It means that you can control their access privileges. So if you have a low privilege process, it won't be able to do everything with these objects. It will need permissions for it. So why do we need them in general? There are graphical objects on Windows that are running on your desktop. You have windows, menus, hooks, and stuff like that. So they are not securable. Any process can access any window on your desktop and manipulate it. So you need these objects you can use them as containers in order to contain these graphical objects and enforce security. So these objects are structured in a hierarchy. So each session can have many window stations, and every window station can have many desktops. So each session has one interactive window station, which is called Winsta0, and it can have many interactive desktops, but the user will be able to see only one interactive desktop at a time. So let's talk a little bit deeper about sessions and what they are. So basically they represent a user logon session. So if you have many many users on a machine, then you will have many sessions. Here in this example, it's a server that has many users connected to it, so there are many sessions that you can see here. So session 0 is a little bit unique because it represents the system user session, and it's isolated from all the user sessions. So on session 0 are all the services and user mode drivers running, and on the other sessions all the users' windows. And there is isolation between them. So one can't affect the other and vice versa. So let's talk a little bit about window stations. So it's basically a security boundary. It contains a clipboard, an item table, and one or more desktop objects. It contains a keyboard, a mouse, and a display device, and it's associated with a process. So the interactive window station is the only one that can interact with the user. There can be other window stations that are associated with services, but they cannot interact with the user. So one interesting thing that we found during our research is that the Chrome browser implemented a sandbox using these objects. So what it does is basically whenever you open a new tab on Chrome, it will generate a new process, and each of these processes will run on a different desktop and on a different window station. So there will be usually one of these processes is used as a hypervisor. It has handles to the default desktop and also to the alternate desktop, as you see here. So the communication between them is made using named pipes, and these processes will be isolated. They will run on a completely different desktop and a different Windows station. So if someone goes to a bad website and gets code execution in his browser, for example, the code will run on a different desktop and it will be harder to exploit the system. So let's talk a little bit deeper about desktops. So a desktop is a logical display surface that contains UI objects, windows, menus, hooks. It's used as a container to create and manage windows. And the same way a window station is associated with a process, each desktop is associated with a thread. By default, there are some interactive desktops on Windows. The default one is the one that you always use, the one that you run your browser on, the one that you open and see all the windows. And there is the WinLog on desktop that we will see in a short while. So the user can interact with only one of them each time. So if you look at Process Explorer here, and you look at the WinLog on process and see its handles, you will see that there are 3 handles. There is the WinLog on desktop, the disconnect desktop, and the default one. So let's see some examples of what is the WinLog on desktop. So whenever you press Ctrl-Alt-Delete, you will get this screen. This screen is actually another desktop. It will go to the WinLog on desktop and present it to you. So whenever you're in this desktop, you cannot interact with your original desktop. You cannot do anything. You cannot close any windows there. You cannot interact with it. You can't do anything. The only way to get back is to choose something here, and behind the scenes, the operating system will bring you back to your original one. So this is another example. And the last example might surprise you a little bit, but the UAC prompt that you see here, this happens whenever you try to run an application that requires more privileges. It will ask you if you want to make changes to your computer. So this is actually also the WinLog on desktop. It's another desktop. What you see behind is just a screenshot of your original one. So the only way to interact with your desktop, with your original desktop, is to choose something, and the operating system will bring you back. So this feature of multiple desktops was introduced since Windows 2000. There is an API for it. You can create desktops programmatically. It has many legitimate uses, as we've seen. There are security applications that use it. You can work on parallel desktops and do open applications and work on them in parallel. There's the Windows logon and logon screen, the UAC, the Control-Delete screen, and also screensavers usually run on a different desktop. So this is an application by Sysyn Channels. It's called Desktops. It allows you to create many desktops and work on them in parallel. the only way to go from one desktop to another is to use a hotkey, and this application will switch you back behind the scenes. So how a process knows which desktop to be associated with. So whenever a process calls a graphical function, Windows should assign it with one desktop. So it's assigned according to the following rules. So you can use one of these APIs, the set thread desktop or set process window station, in order to manually configure which desktop you want to assign to which process. If you don't use this API, it will usually inherit from your parent process. And if you don't have a parent process, you can specify it in the startup infrastructure. So whenever you create a new process, one of the parameters that you put into it is the startup infrastructure, and this structure contains the name of the desktop that you want to assign your process to. If you don't assign it to the desktop using the startup infrastructure, it will simply assign you to the default desktop. So let's do a little recap. So we talked about what VNC is and how it's being used. We learned about sessions, window stations, desktops, and how they're used as containers for the graphical objects on your desktop. And we learned that there can be many desktops, but the user can interact with only one of them at a time. So now let's talk a little bit about financial malware in general. So you probably all know what this screen means. This is the login page of a banking applications. Almost every bank nowadays has one. So there are many in many languages. You probably use one of these at home or at your business. So financial malware is basically a toolkit that is designed to exploit these applications. So what happens when you have a malware on your machine? It usually steals your password, sits and waits until you log into your banking application, and then it will try to make transactions behind your back that you don't know of. So malware uses many techniques in order to steal your credentials. There are web injections, form grabbing, cookie grabbing, keylogin, and many more. We will not talk about all of them, but we'll talk a little bit about web injections because it's the most common method and it's pretty interesting. So the way it works is that malware will usually inject itself into your browser, and then it will hook some functions that are responsible for the traffic from your browser into your browser before the rendering. So in this way, malware can manipulate whatever the user sees. So for example, if this is your Google account, your Gmail login page, and this is a clean machine, for example, like here you have a field and it says that Google will never ask for your grandmother's preferences. If you have a financial malware on your machine, it may alter the page to look a little bit like this. So it will have another field here, and it will ask you for a grandmother's favorite pet, for example. So usually malware do it in order to get additional information that they need for making a successful transaction. So now or will continue.
Thank you, Pavel. So let's continue with financial malwares and hVNC. hVNC was introduced to the world by infamous Zeus at around 2007. It allows the attacker to actually use the exact same machine as the victim. We'll elaborate more on this in next slides. In general, hVNC alone is not enough to commit a fraudulent transaction. You will need some more information. Usually you will need at least the user credentials and some other stuff. Most modern financial malware use embedded hVNC model. In general, if it's a good malware, it should have hVNC embedded in it. So you can see it in Zeus, Gauzy, Dridex, NeverQuest. Almost any good malware should have, or bad malware should have hVNC module. Let's talk a bit about the evolution of hVNC. So in the beginning, there was, when you entered the secured website, you had the password validation. And to combat this, malware started using keyloggers and form grabbers to steal the password from the users. Then website got a bit smarter and started using IP and geolocation validation. To bypass this, malware started using SOX proxy server. Usually what would happen is that the fraudster would open a back connect channel, meaning the client will connect to the server, or the server will connect to the client, and not the other way around. And then the fraudster will have the exact IP and geolocation as the victim. And lastly, we have today in many secure websites, they embedded the browser and system fingerprinting. And to combat this, malwares use hVNC. Of course, there are many steps that we skipped. Today, there are one-time password, two-factor authentication, SMS. We won't discuss them in this talk, but they are there. So what is hVNC? It has the same capabilities like regular VNC. It's just hidden. It runs on a different desktop. It cannot see the actual user desktop, and vice versa, the actual user can't see the hidden VNC. It makes sure that no one is able to switch desktop by hooking the switch desktop API, and that way it makes sure it's never called again. And the most important thing about hVNC is that it has the exact same browser system fingerprint as the user, or almost exact. That prevents from the latest detections to detect that this is a weak fraudster machine. As we said before, it uses back connect, so the server sends the connection back to the client and not the other way around. This allows the fraudster to bypass all the NAT, the firewalls, the whole mess of opening a port in the victim. All the fraudster has to do is just open the port in one of his dedicated machine and is ready to go. It's a slightly modified RFB protocol to authenticate the malware. The fraudster really don't want anyone else to connect to his machine to steal the money that he wants to steal. So they added some layers of authentication. And one more thing is that it can be used to log into active web sessions, meaning that if the user is logged into Facebook and has a session saved, the fraudster can also do it. One important thing is that it must implement all of the Windows interactions by itself. Pavel said before that there can be only one interactive desktop at a time. So if you want two interactive desktop at a time, the malware must implement it all by itself. He must implement the window manager. He must know what window is where at all time. We will see later how he does it. So in general, in order to start the hVNC process, a malware process is calling the create desktop API. This creates a hidden desktop. Then the malware does set for a desktop, and the hidden desktop is assigned to the malware. And then finally, the malware does create process, creates new explorer. This will provide the fraudster with taskbar, start menu, desktop icons, and make his life much easier. To conclude the second part, we talked about some financial malwares, how it works, web injections, and the basics of hVNC. Now we'll talk about GOSI, ISFB. This is the hVNC model we reversed. So GOSI was also introduced at around 2007, and today it's considered one of the most widespread financial malwares out there. It also has one of the best hVNC models that can be found in the world. This is why we chose to present this module and not others. In general, it's based on the hVNC source code of Zeus, but it's heavily modified, and they changed and upgraded many things. If you guys want, GOSI has this debug version. You can download it from Viti. It's a debug version of GOSI. They made it by mistake. The fun thing about it is when you run GOSI, it will tell you whether it injected the code, downloaded models. It will tell you everything it does, and it just gives it to us for free. And the last year or so, GOSI became an open source malware when unknown player leaked its source code. You can find it on GitHub. However, the hVNC module is missing from the source code. We might relate it to the fact that hVNC module is one of the most advanced code that there is in malwares, and they do extra work to keep it protected. A little bit about how we found and how we decrypted the GOSI hVNC module. So in general, the hVNC module is downloaded from a remote server. The module is then encrypted with two layers. The first one is a serpent cipher with a randomly generated key that is appended to the encrypted module. And the second one is that the serpent encrypted hVNC module and the serpent key are encrypted again using an RSA cipher. In order to decrypt it, we had an encrypted hVNC with an RSA key stored in the binary. We did RSA decrypt, then we were left with encrypted hVNC and a serpent key. We did serpent decrypt, and we got the decrypted module. Today, when we have the source code of Gauzy, it's much easier to do it. You can view the source code, see all of the flow of the encryption, and decrypt it. Gauzy hVNC module injects code the same way Gauzy does. It's a pretty neat technique. So in order to do it, what the malware does and what the hVNC does, it puts hooks in all of the create process Windows API functions. Whenever a new process is created, it modifies the target to make it run in a suspended state instead of the regular state, and change the entry point to an infinite loop. Meaning it will jump 0, then the thread will resume and will be stuck with the infinite loop. Then Gauzy will continue with his own load library function. Gauzy has his own implementation for it. He will load the malicious DLL, and then he will change the state of the process he will suspend the thread again in order to restore the entry point back. Then he will resume the thread, and we have an injected process with the malicious Gauzy DLL inside. How the hVNC server authentication works. So most hVNC modules send the unique identifier of the malware to the hVNC client in order to authenticate it. A regular VNC will not work out of the box. We had to patch it and reverse it a lot in order to make it run. So in here we can see the unique identifier that the server is sending to the client. And after the authentication phase is over, we can see that the RFB, the regular protocol, is initiated. It will be much easier to understand than to see it in the demo. Some browser manipulation that hVNC does. Actually, it has a code to deal with almost every common browser. Internet Explorer, Chrome, Firefox, Opera, most of the common ones. And in general, one cannot open the same browser in 2 separate desktops with the same user profile. And now we will see how Gauzy deals with it. So whenever you try to open Chrome in the hVNC window, it will not work if Chrome is already open. To deal with it, when you start Chrome in hVNC, it will copy the whole user profile, meaning the whole user data folder, to a different location, and it will set the new Chrome to work with it. You can see in here, it's a little bit small. Later slide we have it bigger. You can see that the user data folder is changed from the default one. And in here you can see that we read file from the user data and copy it to another location, and then read another file, and copy it. In general, just copies the whole user profile to create it somewhere else. Some more manipulation it does to Chrome. The browser might render pages using GPU. It's not good for hVNC because it's harder for him to copy it. Later on we'll discuss how he shows the screen and why DirectX is a bother for him, and graphical card is a bother for him. Another thing is that the browser uses sandbox, and that might not play well with hVNC module. So in here you can see the command line that Gauzy hVNC runs whenever you start Chrome. So the first one is no sandbox and allow no sandbox job. Disable 3D APIs, accelerated lasers. You make sure to disable audio. You don't want anyone to hear audio from his screen into the victim machine, and so on. Some manipulation it does for Internet Explorer. So Gauzy hVNC don't want to allow Internet Explorer to merge different frames into the same process. To make sure it disallows it, it does just use this command parameters. No merge and no frame merging. One of the most, I think it's the first malware that I ever saw it in. One of the most interesting features is the virtual registry hooks. The hVNC model hooks registry query functions, all of them in Windows. And whenever some application is querying the registry, it will return a false result for the values he wants. What's interesting about it, or the reason he does it, is to make sure that he won't change any real setting for the user. He will just change it for his session, meaning when he queries a value from his session, he will get a different value than what the user really gets. This way, he doesn't make any permanent changes on the system. Some stuff he does with his virtual registry. He alters many Internet Explorer settings virtually. He changed the protect mode for Internet Zone, the enhanced protected mode, and some more. Turns out that when you use UAC, whether it's on or off, Internet Explorer uses different location to load the session cookies. Use virtual registry to make sure that the UAC is the way he wants it to be. He also uses registry hooks to disable virtual effects, active desktop to remove the wallpaper. It's pretty obvious why he can't remove the wallpaper for the real user, and that's why he implemented it with virtual registry, and it only impacts the photo on desktop. Before I said that hVNC implement its own window manager. In order to do it, the first time that hVNC is running in a machine, it will enumerate all of the current open windows and paint them using a bitmap. Then it will hook all of those functions, the object create, hide, show, destroy, location change, and that way you can keep track of what window is currently there and where is each window located. You must keep in mind that you have to track all of the windows all of the time. You must know which window is on top of which, because Windows doesn't provide it for him. Also, hVNC implemented the virtual keyboard and mouse. He implemented it using post message to the topmost window. He implemented virtual keyboard to make sure it's easier for him to copy stuff from his desktop to the fraudulent one and back. And he implemented screenshot. All of the time the hVNC is taking screenshot of the current desktop. It's using bitBLT and print Windows APIs. bitBLT doesn't support DirectX, and that's why in the few slides ago we had to disable DirectX support when using Chrome and other applications. If we want to take the edge off, we are able to actually watch the fraudster in action with 2 easy steps. All we have to do is open a handle using Open Desktop API and switch to the fraudulent desktop using the Switch Desktop API. Those are the functions. Keep in mind that both Open Desktop and Switch Desktop might be hooked and you might not have access to them, but you can easily unhook them and go to the functions. Okay, we're about to get to the demo. Let's show how we piece the puzzle first. So what we had to do is obtain and decrypt the hVNC model. We had to inject it into Explorer exe, the same way that Gauzy does. We had to direct the hVNC model to communicate with our machine instead of the original one that is hard-coded in the binary. And then we had to come some protocol differences between Gauzy hVNC and the standard RFB. So in the demo, we will see in here the server, or the victim. In here, we will manually inject the Gauzy hVNC model and make it run from Explorer exe. We will make it connect to our VNC by replacing the IP address in the server machine. And we will establish a connection and bypass the bot identifier authentication. In the client, in general, all we have to do is just start up any VNC client while it's in listening mode and wait for an RFB connection. So I'll show you the demo. And it doesn't work on that screen. And now it does. Okay, so as we said, we have the server and the fraudster. It's a little bit small, I hope that everyone can see it. So the first thing we do is open WinDBG. We will attach to Explorer exe, and we will put a breakpoint on when we load the model, the hVNC model. In order to do it, we have to do SXE, LD, and the Gauzy module. Now when the Gauzy model will be loaded into the Explorer, we will have a breakpoint. So now we built up a small injector, it's really easy. Now we inject the Gauzy model into Explorer, and Explorer should stop after the module is loaded. You can see that the module is loaded and we stop. You can see it here. Then we put another breakpoint on WS32 get host by name. After the reversing, we found out it's a good place to stop in. You can stop at other places also. We let it run for a few seconds, and then we had to leave this function. And now our goal is to change the IP of the server. So if we go to ESI +4 in here, you will see the IP of the server. You can see it's the first 4 bytes over there. Our IP is this one. Now we have to convert it into hex digit and just patch the memory in line. We can do it using the debugger. So we just convert it to hex values and change them in the memory. I hope it's viewable from everywhere. So you can see that we put add values from here to those 4 bytes in order to change the IP. And eventually we'll press go and just we put a breaking point for when the connection is established, and we press go. Great. Now all we have to do is open VNC client, the VNC client in listening mode in this machine. Now we will do it. All it takes is just any VNC should work. That's it. Now the server will try to connect to the client. Takes a few seconds, and you see that we stopped at the breakpoint. We stopped just before the authentication. Here's the authentication part. All we have to do is skip it, and we are good to go. So of course you can patch the DLL. In this video we patched it in memory. So we just skip the lines, change the IP address to a new EIP. We had to change another value, because this is what Gauzy hVNC wants. And we went with it. Just detached from WinDBG. Okay, so now what happens is that we have connection established. You can see that the foreign desktop is connected to the victim desktop, and the connection is established. This is what the fraudster actually sees. And the first thing we're going to do is show you the different handles you have. So you can see that Explorer, the original Explorer, has handle to his desktop and to the new desktop we created. You can see that there is a son of Explorer, child of Explorer, also called Explorer, that only has handle to the new desktop we created. When we open Chrome in the original machine, we just first want to make sure that we actually have internet connection. Just can see that we have internet connection. And now we will enter, we can open Chrome in this machine also. It takes a few seconds because it needs to copy the user profile first. And now the browser is opened. So we will enter Gmail at this machine. The user is hVNC demo. The password is 128 if you want it. Have fun with it. Okay, so now we will try to access Gmail from this machine, and we will see that Gmail won't have the session saved. The reason for it is that we started Chrome before we logged into the session, and it copied the whole user profile, including this session, and that's why we didn't have it. Now all I do is just close Chrome and reopen it, and since it copies the files again, it should have access to Chrome and to whatever it was. So now when I open Chrome again, you can see that it has access to the Gmail of the victim. Some other stuff, cool stuff that we had in here. Yes, you can actually see the Chrome in the victim machine. We will open any application. I opened Calc, I think. And you can see that the Calc we opened has a handle only to the new desktop. I mean, of course, it is not being seen by the user. That's essential part of hVNC. Next, we open Chrome, and we can see all the command lines we talked about before. So when you open Chrome and go to the command line parameters, we can see that the user folder has changed. It's a little bit hard to read, I'm sorry. So in here the user data directory is changed to a new user data, to some temp one, and that is what makes sure that you can open Chrome twice and you have the whole user data directory copied to you. Some other features we have is that you can see that in this desktop we copied WinDBG. So we made another shortcut, and after a few seconds it appeared also in this desktop. And vice versa, if we do it in this desktop, we can copy it and it will be created in this desktop also. And now Pavel will continue with some IOCs.
Want to make sure that you have, if you want to know if you have a live session of hVNC on your machine, so some indicators might be that you have 2 Explorer EXEs, and if you look in Process Explorer and look at the handles, you will see that you have a handle to the default desktop and also a handle to another desktop with a different name. So usually also whenever you open a new Explorer EXE on a different desktop, the CTF-mon process will be opened automatically because it's the text input services support. And usually you can see maybe some other processes like calculator or a browser, and you will not see them in your original desktop. You will only see the processes just there. So this way you can know that you have a hVNC running in your machine. So to conclude, the hVNC code is extremely complicated. There are many things to consider. There are registry hooks. You must implement the whole window manager for the other desktop because the user can't interact with 2 desktops at the same time on Windows. It is one of the top tools in the financial malware toolkit. It uses many tricks and manipulations to achieve its purpose. And although it's not new, it's still popular and common today in the online banking fraud landscape. So, are there any questions?
Yes, there are questions.
Hi. I'm just interested, what is like the most effective way how to protect against this?
You want to answer?
Besides running the malware executable.
The most effective way is not get infected with a financial malware in the first place, or to have some solutions that will just remove the malware or keep you safe, or if you're infected, that some detection. I don't know, but there is nothing specifically for hVNC. You just need something to protect yourself from financial malware in general.
Or if you're very tech-savvy, feel free to hook create desktop, and you will know whenever some application is trying to open a new desktop at your machine. That's the harder way.